We are going to talk about carbohydrates. As usual, I'm providing what you need to know for sake of IB. Your understanding is on this page. And now let's elaborate on it. So carbohydrates could be simple sugars such as glucose, fructose, or they could be polymer form of them such as starch and cellulose. Now the simplest of the carbohydrates is monosaccharides, and when they polymerize, they will form polysaccharides. So let's just look at them. But before that, their functions in body is a source of energy, and they are storage of energies. If you have lots of sugar, then it will be converted into glycogen in our liver, and later on we can use it. They are also precursor to some other biomolecules, such as your nucleic acid. Now let's look at monosaccharides. Monosaccharides have this formula, empirical formula. Sometimes we show it as CxH2O. That's why it's known as carbohydrate, Y times. So their empirical formula is that. They always have a carbonyl group, a C double bond O, and at least two hydroxyl groups, OH attachments. Now this carbonyl could be aldehyde or it could be a ketone. So your organic chemistry does not go away. So you have either aldose or ketose. And then when they are in solutions, they form, in solutions, they form cyclic compounds. And there is a Hayward projections that shows the structure in this fashion. The junction that is facing us is usually thicker than the junction in the back. Also in cyclic, this is another functional group that comes to life. This is ether, you should know that. And they never show the carbons in the junctions. So this is Hayward projection, how they show cyclic structure of that. Of course, it's given in your new data booklet, section 34. Now, when monosaccharides come together, they can form, for example, disaccharides, two of them together. If alpha glucose and alpha glucose can come together and give you maltose, by going through condensation reaction between carbon 1 and carbon 4, and this will be a newly formed functional group known as glycosidic linkage, so for carbohydrates, and this is how you form disaccharide. And if you have more of them, then you will form polysaccharide, which is the polymer version of that. And few of them that we should know, starches, for example, the stored energy in plants. Counterpart of that, glycogen, is the stored sugar in animals, in us. And cellulose, for example, is the structural material in plants. Now, two examples of that. Sometimes IB will give you structure like this, and they want you to break it into their individual monosaccharides, which you can do. So you break this two, you go back, and you do hydrolysis, and you have your monomers again. Sometimes the linkage is not just going across, you also have a branch, and carbons have their own notations. This is 1,4 linkage. If you go between 1 and carbon 6, then it's known as a 1,6 glycosidic linkage. And you would have different version of those polymers. This is amylopectin, for example.